Alright, so people joining in, and today we're gonna be designing TikTok. So let's start with me first stating the problem, and then we're gonna all come up with some functional and non-functional requirements, and then we're gonna spend 3 or so hours diving deep into everything and making sure that we've got a really, compared to a regular system design interview, this session is going to be much deeper. So the goal here is for me to kind of start preparing and answering on a senior level. So I'll be trying to take a lot of questions from you, and I want you to be very active here and challenge a lot of things that I will say. So yeah, the goal is for everybody to learn, have a good time. If you need to drop, feel free, no obligations needed, but we're gonna go ahead and start. Alright, so I'm gonna state the problem, and we're gonna start. Okay, so TikTok is a social media platform that is used to make variety of short-term videos, from genres like dancing, comedy, education that have duration of 15 seconds to 1 minute. The app, developed by Chinese company ByteDance, gained widespread popularity by its user-friendly interface and ability to easily create and share engaging content. So that's the problem statement I got. So let's go ahead and start with some functional requirements. So we would need to upload a video that can be 15 seconds to a minute long. We should be able to watch endless amount of videos from any user. We should be able to log in, sign up, sign up, follow other users. We also should be able to like a video, follow. I already said follow. Okay, like a video, leave a comment, watch user profile. So collection of videos by an author. We should also cover things like notifications. When somebody you followed posted a video, and we should also cover live streaming, ability to stream to an audience and notify followers of the stream. Then we also got that. I think that's pretty much it. I think we're gonna be able to cover everything in about 3 hours here.
I
There's
would I
uh-huh.
would also add a condition to computing like a success metric for like how long does the user stay in the app, right? And
Oh
like I
yeah,
would also like mention like we're working across like different countries, right? So we're gonna need like a more
telemetry.
like
Yeah.
yeah, so telemetry, and I would also like just like it's not like given, but like we're working with people across different time zones, so different countries, so we need some more like accounting for that. Okay.
Yeah, we're gonna talk. This is
Uh,
this is just the functional requirements.
okay,
Functional.
okay.
Yeah, we're gonna talk about more about code deployment, security, storage, performance, all the kind of stuff. We're gonna put in non-functional requirements, but we're gonna focus a lot on aspects of deploying code, making sure the code is stable, making sure we have support for dev team. We're gonna talk about deployments, deployment rollbacks, auto scaling groups. We're gonna touch a lot into tier 1, tier 3, tier 5 load balancers. So let's kind of start writing this down. So non-functional requirements. So first of all, we should be able. So first priority here would be low latency video consumption. So that's one of the most important things we want to see, is that the video, as soon as we scroll, we are able to see a video very quickly. The next thing is that we have security. So for example, a user cannot upload a video on behalf of us, other user. So we want to make sure that if somebody uploads a video, it's uploaded under their profile and they cannot use it under somebody else. Now we want to make sure that the code is maintainable. Um, the code is maintainable and split into small pieces. Now we want to make sure that the code is supported. Code is supported by many teams. Kind of goes to the previous point. Many teams. We also want to make sure that we have global region availability, and I would say we'll target 5 nines. And low latency consumption, we will say that we want to load a new video under 100 milliseconds. That's going to be the worst case scenario. We will discuss also telemetry. I guess here kind of mentioned it for the functional requirements, so I guess I'll keep it there. Storage capacity. So let's kind of like dive into some other things that we're gonna have. We're gonna start the session with 1 million daily active users, 1% upload ratio. So that means that every one user out of 100 uploads a video daily. And we'll also have a video ranging from 4 megabytes to 10 megabytes. That's about right. And we will scale this up by the end of the 3 hours to 1 billion daily active users, 3% upload ratio, and much bigger database. Big database size is going to be much bigger to accommodate for a bigger pool of videos. We'll also talk about performance of some machine learning models and how we're going to interact with it. Touch a little bit of mobile development and how the mobile will interact with the application. So, all right. So how does everybody feel so far? Do you guys have any comments? Anything?
I
Yeah.
I have few questions. So,
Mm-hmm.
can you please tell me what is telemetry? I mean, I can you expand a little bit on it?
Yeah, absolutely. So, for example, when we have an application, we want to make sure that we record every single click that the user does. So, user analytics,
Okay.
business metrics. So, this is all telemetry. So, what it basically means, so right now I'm in Excalibur Draw, every single time I click a button, we want to have an event that logs this button. You know, for example, we want to measure engagement. How long is the user engaged with something? If the user scrolls through the video of dogs, let's say they see a video of dogs and they swipe it right away, but when they see a video of cat, they like it, they leave a comment, they're more engaged with the content, they show it multiple times, they share a video. This is all telemetry that is needed to improve the machine learning application, machine learning algorithm, and this is basically used for the business to understand what type of content is monetizable and what type of content is less monetizable. So all this is basically aggregated in the live pipeline that supplies content based on these requirements.
Okay.
Um, so yeah, that's hope that answers your question.
Yeah. Also, the global region availability. What you mean to say is, if a user uploads somewhere in USA, that video should be available to everyone all around the globe. Is that what it means?
Not
Global
exactly.
region availability.
Yeah, not exactly. So global availability means that we have content. We have content delivery network (CDNs) deployed all over the world, and the app should be available in all regions of the world.
Mhm.
So every single country has the server there, and we maintain the server. But yes, it does also mean that if I upload a video in the US, people outside of the US should also be able to see the video and stuff like this. But this more refers to a server presence. So for example, you know, if you're located in US and I'm located in Europe, the video to send me the video overseas is going to be really long. So we do want to an infrastructure that accounts for a server to deliver the video in your region, so that you don't have a big latency for the download operation.
Okay.
So yes, and that obviously the system needs to be very scalable. Um, that is going to be the end of the session. We'll see. We're going to identify the bottlenecks to see if it's going to be able to reach the 1 billion daily active users. And we'll start with the more simpler. approach and kind of work our way up. So that's kind of the goal here. All right, any more questions? Good questions, by the way. Yeah, keep asking questions. That really helps me elaborate and gets me more and more kind of in the problem. All right, anybody has any more questions? And if not, we can start right in the next step, which is going to be back of the envelope estimations. Um, so what we'll do here is that we're going to take our monthly active users, or let's say daily active users of 1 million, and we'll try to come up with how much space and bandwidth we would need for that. So how many daily uploads we have? Daily uploads, we know it's 1%. So 1% of 1 million is 10,000 uploaded videos. So now we know that the size of the video is 4 megabytes. Why is that? Well, because we have a video that's a resolution of a phone is like, let's say 1080 by 720. 1080, every single pixel is 256 bytes. So if you multiply 1080 by 720 by 2560 bytes. Oh no, that seems a little bit too high. Yeah, I'm actually not sure why the video is exactly 4 megabytes to 10 megabytes, but that's kind of given to us. I think maybe 1 pixel is actually less than that. Yeah, I'm not sure actually. Yeah, I'll think about this one.
I looked it up earlier today, and it says like, yeah, about 1 megabyte per video for a 10-second video on average.
Yeah,
If it's
so
standard 1080 by 1920 pixels.
1080.
So for just to keep it even, just say it's just say it's 1 megabyte per video.
Yeah,
Um,
1 megabyte per 10 seconds, right?
Yeah, for the average, which is a 10-second video.
So yeah, we're gonna span from anywhere from like 1.5 megabytes to about 6 megabytes. So that's going to be the size of the video. So we have we're also going to have requests per seconds, so TPS. We have 1 million active users, and let's say we divide our 1 million users, we divide it by 24 hours, 60 minutes and 60 seconds to kind of figure out how many requests per seconds we would get. So that comes out to be about 11 TPS. So that's not too bad of a traffic to serve, but still we would need to account that this traffic is spread all over the world. We can probably even start with one region and then scale this back up. But also something that is important is that we're gonna have peak TPS. So every single server goes through ups and downs because you're ultimately most of your population is going to be located in one way or another. So let's do like a estimate of 2. Peak TPS is going to be 2 times TPS is going to be 2 times 11.52. It's gonna get about let's say 22, 23 TPS. So that's not too bad of a problem to solve. We can certainly get some good rough design started. So from my expertise, my experience prior, a server node that is maybe M4 X5 large, it can serve about 250 TPS of pre-rendered HTML to a client. So we can talk about more about which type of nodes we will pick, but I'm thinking that M4 X5 large is going to be more than enough for this traffic, but we can kind of jump into this a little bit later. What I am interested in is that let's actually assume that we have about let's say the service has been running for maybe 3 months, and let's say that our video storage total, let's say we have about I'd say let's start with the 30,000 videos. And let's say if we multiply by the average of this, so 30,000 total capacity is going to be 3 megabytes times 30,000. So our database is going to be 90 gigabytes. That seems very small because that's not a lot of videos at all, but we'll definitely, the beauty of this would be scaling this up and seeing how much my design will change based on the scale. What else? What else? We also have this is just the total capacity of blob storage. So we also need to think about the capacity for the user profiles, video metadata, and the video stream storage, because the streams are also going to be recorded. So that's something we'll also need to think about. But for now, does anyone have any questions so far?
How did we come up with 30,000 videos for the storage?
It's just an estimated start for the problem statement. We're going to scale like initial 30,000 videos to 30 million by the end of the session. So
Okay.
we're going to the problem of the session is we're going to solve a problem with much simpler constraints first, and then we're going to see how much changes we need to do by the end of it.
Just a minor thing, wasn't it 90 gigabytes?
Oh yeah, you're totally right. Sorry, it's 90 gigabytes. Cool. Yeah, thanks for catching this. All right, if no more questions, let's keep adding the thing. So user profile storage. We would need to keep track of that as well. So let's assume that every single user profile storage is going to be, every single user is going to be like about 1 megabyte. Maybe we'll get some more or less, but on a safer side, let's say it's 1 megabyte, and our total daily active user, let's say it's 1 million. So maybe we say that every 100th user is active daily. So maybe we do multiply by 100, and we multiply by 1 million. So we get that let's see how much space that would be. That's going to be 1 to the 10 to the power of 6. That's 100 terabytes of storage we need for the user profile. 100 terabytes. Now we have we also have another database for video metadata storage. So that's going to contain information about like the user who published the video link, and other like maybe tags, maybe a reference to the table with the comments. So I would say more or less 500 kilobytes. Does this sound right about you guys? So I think 500 kilobytes would be for each entry in this table. And since we're starting with 30,000 videos, we can multiply this by, wait, our design doesn't make a lot of sense. We have 100 million users and 30,000 videos. Yeah, I guess that's fine. We're gonna design it in a way where we'll have like to update it later. So I think let's keep it like this for now. We're gonna make the problem a little bit more interesting. So that's gonna be 15 gigabytes of video metadata. So we already can see that there's gonna be very interesting choice between the profile storage and the video metadata storage, because they're so drastically different right now. So that's gonna be pretty interesting. All right, so let's see. So now we would need another database. The streaming of the video is going to be pretty hard because streams are usually long, and we would need to record them, and we need to provide this information. So let's say stream video total. Let's say we're gonna have about let's say like 4 million stream videos, and let's say every single stream is going to take maybe like 125 megabytes. Let's say it's going to be 12 minutes average, and that comes out to be uh, let's do this in gigabytes. Four, sorry, 4 to 10 to the power 6. Oh, that's 500,000 gigabytes, or let's do petabytes. Terabytes, 500 terabytes, perfect. So let's say 500 terabytes and growing. Okay, does it look like we've got everything, guys?
Give me 1 second.
Oh, we also need some database for telemetry, right? For the user analytics.
Yeah, you're gonna need something separate for that.
So yeah, I'm thinking that I'm going to design my own service. We're gonna curate. We're going to call it a TQL. It's going to be TikTok query language. And if you're asking me why, it's because there is a company that I worked at that had their own query language that's called exactly like this with their name. It's really going to be another architecture that's going to have a pipeline of user events that is going to be pipelined into raw logs, and then it's going to be pipelined into aggregated tables like this. So what this essentially will do is that we're gonna have a click that's going to be, let me kind of give like an example here. It's going to be like user click, and then the raw log is going to be something like maybe encoded like user ID, and then encoded some other information encoded, and then click, and then array encoded is going to be process something like this. And then what will happen is that we're going to have our microservice team owners will have tables, and they will be able to parse user click metric as user click in their table, and then they would be able to do operations like joins, queries, and other add metrics on this in the table. I will touch more on this a little later, but I just wanted to explain what type of databases we need for this. Does this kind of make sense for everybody?
It does.
Quick
Oh,
question. I mean, it's probably going to be kind of trivial, but are you factoring in like storage for like stuff like comments and replies, or?
Oh yeah, that's another thing that I missed right here. So I'll go back to this in a second. Thank you for this.
I was just gonna mention too. Are we just gonna go with like our own kind of some NoSQL, or are we just gonna focus more on affiliate categories? Like if you're gonna make your own query language, is it even worth mentioning like how we're gonna design it, or are we just gonna say like for now we're gonna make our own query language? Then we'll get back to it.
We're gonna design everything. We're gonna design everything. So we're probably gonna run over 3 hours, but we're gonna design everything. I'm basically there's no end for this session. End is whenever you get tired and you don't want to listen to me anymore. But I'm gonna keep designing until we finish. So I will go in depth. I worked on this very extensively. I will focus on designing things that I have a lot of more hands-on experience. So I designed the parts of the query language at work. So I definitely would want to dive into this as much as I can.
Okay, that sounds good. Let's just touch back on the comments like
Yeah.
who that person was just said.
So let's assume that every single video comment storage, let's assume that for every single video on average is going to have like about six comments. Each comment is going to be like 200 kilobytes, and then we have a number of videos. We have 30,000, and let's see how much it would be. 36 gigabytes. That's going to be for comments. 36 gigabytes. That's going to be for comments. All right. So that's that should be it. Okay, so for the TikTok query language, we need we need like a data lake for raw logs, and we would need tables for with aggregated with ag data. So let's assume that we're going to parse. We're gonna be producing one log per action, and every single request. Well, it's actually going to be more than the TPS to the service. So our TPS so just to be very clear, so TPS right here is going to be this is to TPS to the backend API that delivers things, but telemetry is actually recorded natively from the mobile client. So the way how TikTok works in like super high level, we have a mobile app that talks to the backend API, and these events we're going to be emitting from the mobile app before even any API connection is established. So that's going to be much higher than the actual request to the backend server. So I'm assuming for every request that we make to get a new video or to post a comment, we're going to record about 10 actions. So for example, user opening the app, user how long they spend scrolling, their scrolling frequency, how fast they scroll. We can also see where their eyes are looking, how their fingers are touching the phone. So for every single request to the big backend API, I'm gonna say that 10 times peak TPS. It sounds about right to me. So does that sound about right to you guys? I think it's pretty fair. And our peak TPS was again at 23. So let's say 10 times 24, and let's say we need storage for, let's say 60 minutes times hours times days, and let's say at least for 300 days. We're gonna keep logs for 300 days before we can get rid of them. I think it's about industry normal, and this would be if we said like every single row is going to be about, it's going to be about 1 kilobyte. One action is not going to be too big of a size. Yeah, so about 6.2 terabytes of data for this amount of traffic, which is obviously going to increase since once we're going to increase our TPS. 6.2 terabytes of data. And tables with ARC data, it's going to be very close to the data lake. It's just going to be restored and restructured a little bit. For simplicity, I would say it's going to be about 40% more complex, restructured as the raw logs, and it's going to be just, let's say, 10 terabytes for now. So I think this is about it for all the backend envelope calculations. We've got video storage, capacity of blob storage. We've got TPS, we've got peak TPS. We've got user profile storage, video metadata, video comment storage, stream video total, and for telemetry we've got the amount of table data we need for this. So is everybody kind of on the same page? Any more questions, concerns before we go to the next section? Chat?
Hey, Babito, if you're speaking, I know you just want off mic that we can't hear you. No, I think we're good. I think you can continue, Max. If something comes up, we can bring it up later.
But so far, how are you guys enjoying this? Is everything clear? You guys want me to go faster, slow down?
So there's one comment I have or concern is that like using a system design is what, like an hour max?
Would you prefer like
right?
a
Like
shorter
this
session?
is like really in depth, right? But like I guess like maybe later on I would like to cover like what could be cut in this coverage, right? And what could we focus on? Does that make sense?
Yeah. Yeah, I guess that's a fair comment.
No. This is
Uh,
great. I'm just saying that like it'd be interesting to go back and figure
Mm-hmm.
out like how would we actually condense this and explain this in like an interview setting. Does that make sense?
Yeah, I mean, it definitely take me a lot of practice to go faster. So I guess I can do
Yeah,
this
yeah.
more once I have a little bit more experience to get this kind of done quicker.
can you hear me now?
Mm-hmm.
So I think I missed it, but like, what's the reason you decided to create a dedicated query language?
So we want to, in our functional requirements, we have telemetry, and we want it to
Hmm.
be very advanced. We want to use telemetry for for feeding the machine learning models, and we want the
Okay.
telemetry to be used for just data analytics. So this would allow us to convert user clicks into parsed logs, and this parsed logs will be used for system health monitoring. We would be, for example, when the user clicks on something, we can do joint queries and ag metrics on this, but also this raw logs right here, they will be also fed to like KNRE monitors. So there is going to be multiple systems listening to raw logs. One is going to be the aggregated table for like business analytics. One is going to be machine learning models. One is going to be Canary to measure system health. So we're going to
Hmm.
be basically having a lot of listeners. So that's most likely how I see this myself. It's going to be like a Kafka, uh, maybe some producer consumer thing, and we'll have a lot of listeners to this. So I want to have a lot of design to kind of get under the hood. That would not be like really easy to do with the without well it's dictate to query language is going to be basically it's not going to be like my own like actual query language like new SQL. Like we're not reinventing the wheel, but the emphasis here is just going to be like a really big service that's going to have a lot of customers internal, and it's going to have a lot of functionalities, and the actual joins queries and ag metrics will be done um, in the database of choice. If it's going to be like we're going to talk about what exactly and how exactly that's going to work. Does that answer your question?
Yeah. Thanks.
Yeah, absolutely. All right. Anything else? Okay. All right. So now let's kind of talk about the first step. So first step is we have the user. So now we kind of finished the back of envelope sections, and now we're gonna be having like another section where we're gonna actually have the user, and we're gonna have the everything here. So we will not go in depth into security and authorization yet. We're gonna actually try and cover as much overview before we go into like really long, just to kind of get like a really good idea here is that get kind of design and then go in depth before you go in depth right away. So usually in an actual system design interview, I don't think you would want to go in depth either. So I think we're gonna go ahead and start with that. So for right now, let's assume we have the user here, and let's assume that on the right side we're going to have the service. And immediately, with what I would always love to do is that I would love to say that the user, the service, is going to live in something called a VPC. So this is a virtual private cloud, and that is something that also access to a VPN. So this is where all the microservices will live, all the services will live, all the databases will live. But the users will be connecting from their mobile app. So there's going to be an API that connects to our systems from their phone. It's going to be connected with this. So there's going to be multiple APIs, obviously, and all of them are going to live in front of two components. So one of the components, as you guessed, is going to be a CDN for allowing to deliver the content in multiple regions. And another component, let me just have a little bit of space. And we're gonna have load balancers, obviously, that are going to distribute the traffic to the APIs to the scaling groups of the nodes behind the load balancer. So here, what we can see, we're gonna first focus on the video feed API. So this is going to be like this, and this is going to be video feed API. So what this API will again do, we can even supply a little bit more data here. It will basically, this is a stateless connection between the user that will look something like this. So this will request the video feed, and then what it will supply in the request parameters, it will supply the user ID. Though the user ID is going to be needed to fit in for our recommendation system, and this user ID also, the reason why we supply it in the request params of the API is because we want to maintain a stateless connection. So this request can be routed to any server without any particular need to be routed to the same service again. So if the server dies or something happens to it, we can always basically reroute this request to the next available server. So user ID will take some UUID, and we'll think about some other parameters we would want to supply to this API. But the idea behind this is this API has to be very simple, because what we want to do is that we want to supply this user ID to our internal machine learning model, and then let that thing figure out the rest. And since this is not like, I'm not machine learning expert, we're not going to touch too much on the machine learning system, but what we will do, we're going to touch a lot on what we're going to supply to it. So the telemetry service and how that exactly works, and how that would feed the machine learning model. We'll talk more about that. So is everybody kind of clear on what's really going on here? Chat? Are you still with me?
Yep.
I'm here. Sorry, we're doing the emoji reactions.
Okay. Yeah. Sorry, I cannot see the emoji reactions, so Edmund will help me out if you guys put something up. So alright.
Yeah.
Cool. So any questions about load balancers, CDNs, VPC, the API, the server connection, the user, the mobile app? Any questions so far?
Not for now. Usually, in my experience, I'll just say like for a CDN for LB load balancer on there, like you don't usually have to go in depth, at least in my experience. But yeah, is that correct? The correct assumption, I guess.
What's
What
that?
we're going through right now.
What's
Like
that?
you don't have to go too much into the details of describing like for CDN outline or load balancer.
I think
Right? Like we're just.
yeah, I mean, I think it's pretty fair comment. Actually, depending on the role you interview for, I think there is some desired explanation needed for maybe a little bit more close to the end of session how exactly that works, because there's actually more than one way to load balance stuff. There is a load balancer in front of an auto scaling group. There's a load balancing in front of a DNS.
Yeah, I'm familiar with that. Yeah. I
So-
just like if it's like a product role, you just say like load balancer, bam.
Yeah, that's
But if it's like infra, it's gonna be more specific. Okay, yeah, that's
Right.
just my only concern.
Yeah. So yeah, we can. I guess I'll definitely want to discuss that, since we have Babita who works at GoDaddy. I'm assuming his system design is actually pretty strong. So I'm looking for like really good comments on that. Yeah. Okay. So now let's kind of talk about once we have this user ID and we want to talk to whatever the service. So now it's time to kind of dive a little bit more in depth about discussion, how we're gonna store everything. Now that we kind of have it designed, so what I'm gonna do here is that I'm gonna outline another section, and I guess that's something that I probably should have done before I started drawing this out, is to talk a lot more in depth about what type of databases I'm looking and how my tables would look like. And yeah, I guess we'll start with the most simple one, and then we're going to be discussing trade-offs and pros and cons of everything so far. So for this one, we're going to do S3 S3 storage. And so what this S3 storage will contain, as you guys guessed, there's going to be the actual videos. So that's going to be the actual video. So it's going to be just objects or video. It's going to be MP3, WAV4. So whatever the format the video is, we're going to accept that. We're going maybe some Apple. I think Apple has some other weird formats. So whatever the format is, we're going to have that. Now let's kind of talk about kind of more complex things. Is the choice of storage. So we can go many routes here. So if we choose SQL, right? If we were to choose SQL, so what we'll get? We'll get obviously relational data. SQL is a natively relational database that is really good at joining and having multiple tables of related data. So one of the things, we can have a user table with a primary key of user ID, and we can have foreign keys of that connects the tables for videos, connects the table for their comments, for their storages, which would make it easier for us to follow that. So that is something we can consider. And what we can also have is that we have transactions. There is also many things that we can do to scale data SQL. We can do some sharding to figure out if we can deploy database over the many nodes. We can shard based on the user ID if we have like a really big user table. So we can do that, or we can use something like a CockroachDB for distributed SQL. So we can use something like that for SQL, and we have some advantages coming to that. The disadvantages of SQL here is that we need to have a pretty structured data. We need to have pretty structured data for every single table, and that forces us to have all the databases to be pretty much we would need to define it very strictly about what we'll do with that. So pretty structured data, and then that's something that I guess we can achieve here, but it would be a hard limit if we want to maybe collect the video metadata, right? So if you think about video metadata, it's not going to be very structured data. And we'll definitely not have a lot of structured data for the TikTok query language, for the TQL, because the parse logs are pretty much never going to be of any structure at all. It's going to be always pretty random, and we would not want to limit our internal clients to have a certain fields only. So that's something that would definitely not work out for this, and depending how much we would need the TQL and the video metadata to be interconnected with the rest of the application will influence my overall decision here. The other disadvantage of an SQL is, from my experience, is actually very costly to run and scale this advantage. It's actually very costly to scale SQL. Very costly to scale. It is much, and it's much more work too. So stuff like sharding and all this kind of like provisioning and replication, which is actually, we can have primary to primary replication here. We can have primary secondary replication to talk about how we're gonna be achieving the consistency. And by the way, I think that another important comment here is that consistency is actually not important. If somebody uploads a video, we are okay with having more or less eventual consistency. I'm okay if we would need to wait for a while before I can see a video that's been uploaded. So the focus here is again on latency, and achieving very low latency with SQL is definitely possible, but that does come with some disadvantages. So that's SQL. And now let's talk about NoSQL or NoSQL. And what we'll get is actually we have quite a bit of options here. We can consider either MongoDB, which is a document based storage. We can consider Cassandra, which is columnar oriented storage. I think this is there is other like NoSQL options like graph databases or other ones, but these two like the ones that I think somehow will fit. So the pros of that would be that we can have document is like JSON-like format of storage, which will allow us to just basically store JSON blobs and have like a primary key, like a connection ID for every single video and store that. So we'll actually probably need to have more than one type of database. So I'm definitely very interested into feeding the machine learning service with documents instead of keys to relational database. So the telemetry will probably use NoSQL because we will want to have a very flexible opportunity for teams internally to store and provide data to each other, to the BI applications and machine learning applications. So we can think about stuff like this that can be stored in the document like database. We can have like video ID, and we can have some hash to this ID. We can have some hash, and then we can have like average watch time, and then we can have like a precise like metric how long this video was watched. We can have like count of this video, and that like count, for example, is going to be some number like this. And then we can have like some very interesting metrics like time to achieve like 10,000 likes, right? We can measure things like this. Again, going back to I think Dave's question, why do we need the TikTok query language, is because by doing very powerful joins, we can achieve and customizable metrics like time to achieve 1,000 likes. We can measure this in seconds since the video was uploaded. So for example, it took this many seconds for the video to achieve 1,000 likes. So for data like this, I would want the teams at the company to be able to customize them and be as creative as possible. So the decision here definitely falls for the document-like storage for everything single thing that is related to telemetry to be MongoDB document-based oriented storage. Compared to a more stricter SQL approach, it's going to be very cheap for them to scale. There's going to be a lot more records of this, and yeah, I would definitely would be very happy to see the document instead of SQL. All right, now I know I talked a lot, maybe like 20 minutes since I last kind of like paused. I really want you to guys ask a lot of questions. I want you to poke into my knowledge as much as possible. I prepared a lot and I really tried, but I want you to ask questions and kind of like stop me, talk to me about the stuff, challenge me. Yeah, happy to answer some questions here.
Maybe you'll talk about this in a little bit, but how would you accurately measure, for example, time to achieve 1,000 likes?
Yeah, absolutely. That's actually an amazing question. So this is something that we'll do as a join. So let's kind of think about how the query would look like for this. It's not going to be SQL, but let's just pretend I'm writing some custom language that we'll have, and then we'll for example select from like video table, and then video ID is going to be supplied as like, let's say, in some hash. And then what we'll do is that we can do this. We can select let's say likes at time, and then we can do 30 minutes intervals. and this is completely like SQL pseudocode. Well, it's not SQL, but what this kind of returns is that we're selecting from video table, and then we're selecting the video ID, we're selecting the column likes, and we're selecting the hashed intervals at 30-minute intervals. So what this kind of will return, like an example of that, it will return an UTC time, for example, 2024, 01, 22, and then we'll return, let's say, 01, 10, 10, and then I think that will be like another column for seconds, and then we'll return number of likes at this timestamp. And what the next row, what we'll have, is exactly the same practical entry, but it's going to be the metric. It's going to basically be 30 minutes after this. So if this is as well 40, 10, I guess that's a little bit too much. Yeah, let's make it like this: hours, minutes, seconds. 30 minutes later, let's say this was already. Let's say this was like 320 likes, and now it was like let's say 5,000, like 15,000, right? So we basically capture with the up to like 30-minute accuracy how long that would take us for us to measure. Since we storing logs up to 300 days, we would be able to do these types of calculations with our service.
I see. Okay. So would you have some kind of like I don't know, like cron job or something that every 30 minutes gets all the like counts for all the videos, or
We will, yeah, pretty much what will happen is that every single time, this actually will be more precise than 30 minutes. So every single time the count is updated, so we'll have like another smaller like internal API that it would be able to like give in like a video ID, and then let's say some sort of hash, and then it will do a count. It so for it to actually to work concurrently, it will just do an operation like on, and what this API will do is that it will concurrently aggregate all the likes, and just like let's kind of put an arrow. So this is an API that is going to be sent from a backend to another backend, and what it will do is that let's say there's like 1,000 of these operations count on. We will collect all the operations and update the final like count. And this will actually also contain the information about the user who liked it, so we can see, and then some reference to the user. And this is just needed. The question, just to answer right away, the reason why we need to separate the operation is to allow it to work concurrently at high scale. But to answer your previous question, what this thing will do is that we'll record a log whenever this backend service would receive this operation to update the like count, and obviously it's going to return a timestamp of 2024 01 10 at 01 10 35, and it's going to record the exact precise number of likes at this timestamp. The reason why I selected 30 minutes in my query language is that it's going to be very computationally intensive to kind of like record everything and store this at a time. Two things to say: it's going to be completely asynchronous, so it doesn't affect latency in any way, because this is just a BI machine learning type of operation. And secondly, it doesn't have to be fully accurate. We'll probably would need to adjust this 30 minutes interval to kind of see based on how long it does take for this video to take on average. But to be very very precise, this would be just n minute intervals, depending on what the team will be able to find this is just an aggregation for this many minutes. So it's completely customizable instead of just looking at every single record, because it's possible that we'll actually have more than like 5 or 6 records per second. So it's not, there's no point to kind of like return all the rows for every single 5 or 6 seconds. We want to aggregate based on the n closest minute clusters instead of kind of looking at everything. So we can kind of make some metrics like this. Does this kind of answer your question?
Yeah, it does. Thank you.
Yeah, absolutely. All right. Any other questions about any things we had so far? Edmund, do you have any questions?
No, you guys covered it pretty well, actually. I'm just kind of focusing on taking these notes at the same time right now. But I think the ball, unmute the mic. But for now, let's just keep going over it. I don't think anything will have that's pressing.
Cool. All right. Let's kind of keep going then. All right. So let's talk about then the database. So I think the chat agrees that the decision to go with a document database was a good decision, and we kind of talk more about how exactly that will be used. So I think that what I will do is that for video table, user table, and user data, I'll go with a distributed SQL approach. And the reason for this is because our database, our functional requirements have the opportunity to, first of all, share, sign up, and follow other users, like a video, leave a comment, watch user profile, notifications. So this is a pretty structured data. So we know that now kind of gonna here use some tables, I think, for some of our options, but it's going to be a user table. So this is going to be user table. Yeah, now we're also going to have a video table, and we're also going to have inside of the video we also need a comment table. And we also would need we'll also need a streaming table, because we need to collect the information about streams, and they're not exactly like videos. Actually, let me go ahead and take these tables and kind of like put them in our own section. And in this section, we are going to be. And by the way, after this lecture, it's not definitely not a lecture. After this event is done, I will share the link to the Excalibur with all of this. So if you guys would be interested in playing around with this, more than welcome. So this is going to be the SQL approach for the main application. And the reason for this is, again, our data is pretty structured. Data is structured. I can't type today. And that data is structured and relational. We can partition and shard the data for scaling. We're scaling the tables as we go. We'll talk more about how exactly this is done, and we can leverage primary to secondary to allow low latency with eventual consistency. And I'll go in much more detail into this, much more depth. And this is kind of like my bullet points, why exactly I made this decision and why this is important. Let's go here, and I will well, S3 is not going to be the, obviously it's not, no, it's just a blob storage for the videos, but I'll just put it here because we're going to be relating to this, so I'm going to just put it right here. And then here's going to be also a stream table. And yeah, that's going to be it. So now I'm not going to add every single field possible, but I'm going to be pretty exhaustive with everything that I do. Wait, why is my screen so much to the left? Ah, okay, I need to scroll like this. Okay, cool. Let's kind of go forward and talk about everything. So what do we need for the user table? So we would obviously need a username. How do I make this small? Here. Username, which is going to be a char set. We're going to have a hashed password hash. We're going to have, let me actually make this a little bigger so we can kind of have like more room to play here. Now we're going to have a, so the primary key here in this table is going to be the username. And now we're going to have some other metadata about the user, like link, avatar, profile picture, and this is going to be a link to S3 resource. So the S3 storage will contain all the static objects like profile pictures, links, and so forth. So that will be here. Let me just move this over here. And other metadata about the user. Now video table is a little bit more interesting. So here, the primary key here is going to be the video ID. Is going to be primary key. The secondary ID is going to be the user ID who uploaded the video, and secondary key, and we also need a comment ID. That's going to be another secondary key that is going to link us to the comment section, because we would need to somehow quickly figure out that this database is going to be related to the comments, it's going to be related to the videos, and this another thing right here is we also need to be related to the S3 link to the video. So just kind of like a reminder, so the videos are actually not stored in the actual databases. They're stored as a blob object in the S3 storage, and how it works is that we have a signed URL from the S3 that is returned, and this is what basically gets uploaded on your mobile phone whenever you are, well, you want to watch a video. So this would be all the important things, and then we're gonna have metadata like tags, title, description, and then other things. Now goes the stream table. So stream table, and by the way, this also has like timestamps of creation and other data. The same thing, other metadata of the user, just to be a little bit more descriptive. Timestamp created, follower count, follow count, etc. Now we have a stream table. So in this stream table, we're going to, I'm not going to dive too much into depth about how we're going to stream the data, but we will we'll kind of cover that this belongs by user, and we'll cover that this one has metadata about the stream and reference to the comment ID table. So this goes, I guess this is easier just to see would be from this perspective. Now we'll clearly see that the stream table is going to be referencing the user table, and it's going to be referencing the comment table as well here. Alright, whoever joins, welcome back, or welcome. Comment table. Now the comment table, the primary, I completely forgot that the primary key for the stream table is going to be the stream ID. Stream ID. Alright. Alright, any questions so far? I know we've covered a lot. Any questions on SQ, why we chose SQL? On these 3 points, why we chose why we chose SQL. Any questions or comments about the tables, how they interact? Yeah.
Yeah. Can you explain the stream table, what it actually does and what is actually used for?
Yeah. So, are you familiar with streams on TikTok in general?
I mean, if you keep scrolling, you need to keep getting a video. So
No, no,
the
no.
video that comes.
No, so yeah, I guess that's a good like a product explanation here is that stream is basically when you see a user, they can have like a live stream where they would show the instead of like a video they would just show themselves, and it's gonna be like a long type of video that
Okay.
of live action basically.
Yeah. Okay. Got it.
So
Got it.
yeah, so the key thing we're gonna like consider here is that the streams are going to be live, and they would be focusing. The focus of this system design would be um, notifying every single follower that their favorite content creator is streaming, so they can hop on the stream and watch it live while it happens. Alright, chat. Any other questions about SQL approaches, the reasons for it, the video storage, why S3, how does it work, the primary keys, secondary keys, how all that works?
I also wanted to mention, don't we need a followers table wherein we know who's following whom and so on?
Yeah, I'm actually not exactly sure if it can be achieved with just a user table. Yeah, if somebody can help me out with this, I appreciate it because I didn't really think about it. Bobito, would you know? Would you have any ideas?
So sorry, the question was like followers.
Yeah, how would you handle followers? I'm not
I
exactly sure. Yeah.
I imagine it can be in the users table. Like,
Mm-hmm.
uh, are you asking like
Do we need
how
like a
you would?
separate table for this? Like, because like I guess what I'm thinking here is that um, you can have like a follower list, right? Because this is a table. You can have like multiple followers, right? So how exactly would that work? I'm not exactly sure.
Uh, yeah, like a follower list or
Is that possible to have like in a database like this? Yeah,
uh, yeah, why not? Like you can have lists in a database, right?
that's a good.
Yeah, you could. I honestly, what I think you could just have like a full like relational table. That's how I would do it.
How exactly?
Like have a followers table, right? Right. You could have something separate like that, or you could just have it
Oh,
within the user table itself.
yeah, you could do something like that too. You could have like a followers
I
table.
mean,
Yeah.
okay, even okay. If let's say if I create the followers table here, right?
right?
What are going to be the keys for this and how? Right. So we have followers, and
I
then
mean, I would. It's pretty pronounceable, right? You have user ID and you have follower ID, right? Right, and it's all based off the user's ID.
so
That makes sense.
not necessarily. Can you repeat that again?
Yeah, I would for now keep it simple, right? So you have a two column, right? You have two fields, right? You have the user and then you have the follower, right?
Ah, okay. So UUID and then follower. Also, just
Right.
like
And those are all derived directly from each user ID, right?
mm-hmm.
You see what I'm saying?
Yep. So this
And
is
that's the most concise, if not like the most, because I know it's going to be super efficient when you're doing searching for, and it's like the most normalized form that I could think of for that
user.
database, for that
Okay.
specific context of it.
Okay. So just to be yeah. I'm gonna do it like this. So we have the user and the user table user
Yeah.
UID, and the follower table will kind of derive the. There's gonna be every
Yeah.
single entry in this database is gonna be the user and the follower.
Yes. Bovito, that is that a good approach? I mean, that's the first thing that came up in my mind. I don't know if there's something more advanced, but like that's like kind of
I
done and
I
dirty.
I think that's a good like I'm not too familiar myself, but I think that's a good approach.
Babita,
Yeah, I'll do
what's
some research on it later. I highlighted it in my notes.
yeah
It'll
yeah.
be good to take a look
I
at
think I
after.
think we're gonna have to have another session on specifically this. Databases is my weakest aspect of system design. So yeah, there
Sorry.
is a
I know
Jason.
you said another session, but imagine a 6 hour interview for just designing TikTok.
Yeah,
So sorry, just to clarify, because
yeah.
I'm a little bit lost. So is it just that we're just gonna have this followers table and there's just gonna be two columns, user and follower, and there's gonna be a row for every single
Yeah,
user follower relation?
exactly.
Okay,
So
okay, got it.
Yeah,
there's gonna
very
be like
straightforward.
Babito.
And I guess like the added benefit of this also is like I know that I'm not really familiar with TikTok, but like on Twitter there's like you can have like super followers or something. So like in the
Oh
future you
yeah,
could like
we could,
expand this with like another
It's
column.
yeah.
that's the benefit. So you can also add weights to the priority of the relationship too.
Oh,
Yeah.
interesting. So yeah, in
That's
this case for now, right now, it's gonna look exactly this like user Babito and follower Max, and that's gonna just show that I'm following Babito. The
yeah.
problem with this gonna be, the problem with this gonna be once we scale this up, is when we have let's say Babito is streaming. So how difficult would that be to find every single follower of Babito and notify them? So with this type of approach, that's something I want you two guys to
So
think
what I
about.
would do is I would also embed this. So I would keep on running the of Bobito's followers in his own user table, like directly.
What's that? Repeat this
I
again.
would
Sorry.
keep I would keep I would like keep a essentially like an already queried like result of each user's followers in their own.
Ah,
Does that
okay.
make sense?
And
So like the followers table would mean more for like an analytics, like an OLP, OLAP, like pipeline, right? For like the analytics team at TikTok, right?
yeah,
If you just want to, if you just want to notify the users of who's streaming, you want to directly call from the user table. Does that make sense?
yep. So let's run a cron job that would recompute the query. So what we'll do is that we'll query result. It's going to have. Oh wait, do you want to execute the query every single time once we run this, or do you want to save the actual result of the query here?
I mean, it's up to the needs of the analytics team, right? Like
No, we
honestly,
want to do it
and
for the notifications. For example, you started streaming, and everybody needs to
right.
get a notification, like a push notification. So
Yeah,
we
yeah.
could.
So if a streaming is initiated, right, it's going to go through all the followers via the user table, right? We're not just going to goddamn like do a query research on the max followers table, entire like I don't know, like whatever that locality that is, right, or that region, right? We just want to query the followers of that specific user. Does that make sense?
Not really. Can you repeat that again?
What Bito? I just saw you unmic yourself. Couldn't
No,
hear it for a
sorry.
while.
Yeah, you can. I just wanted to. So, based on what you're saying, like, let's say I follow someone, and then they start streaming. Like, I follow someone a second before they start streaming, so then I wouldn't
Okay.
get the notification, right?
Yeah,
Because
yeah, that's the kind of downside. So I'm really trying to think. Yeah, well,
I
technically, if you don't save the result of the query, but you could save the query itself, but I'm not really sure what's the benefit of it.
I mean, you could have it where whenever someone else follows a user, right, they're going to get a response to see, like, you could have a state for every user where it's streaming or not streaming, right? And if someone ever follows it, right,
Oh,
they will get
you
the
can
streaming
update the
notification
result.
immediately.
Okay, so every single time somebody follows somebody, the query is re-executed.
Yes.
Okay, and how would the
And
result of this query would
wait,
look
wait,
like?
and it's not even, it wouldn't even be a query, right? It would just be like, I follow someone, right, and I get a notification back, right, like on the back end saying, like, oh, this person live streaming. Here's a live stream notification. Does that
So,
make sense? So, like, what I'm trying to say is, like, so let's say, okay, so we got two cases, right? Let's say, like, yeah, I'm an OnlyFans star, right, and I start streaming,
uh huh.
right? So I click stream, and my since I'm initializing the streaming, right? Essentially, your backend service is going to go through my specific list, right? That's like essentially like embedded or like tied to my user profile. And it's going to go through and notify all the people, right? Now,
Mm-hmm.
let's say that you're trying to have a spicy evening, right? So you're like, oh, look, Edmund's streaming. So you click on me, right, to follow, right? You don't
Yeah.
know that I'm streaming this yet, right?
Yes.
My state, right when I started saying that I was streaming, right? My state immediately says that like I am streaming. So whenever a new follower essentially tries to follow me, they will immediately get the notification. So instead of waiting for you to be added to my follow list, right, and then it queries again for the entire thing, all that you're doing is you're immediately get that on a live notification. Does that make sense?
So you want to like have a field that says like streaming, and
Yeah,
then make it
just
like
like
a
it feels like
boolean,
that. Yeah, literally be
but instead of like I guess, uh, uh,
yeah, and there could be a stream ID associated with it too. All I'm trying to say is instead of waiting for you to be inserted into like my list, right, and then we query through that list again, right, or we can go
mhm.
from back to there you go.
So followers is gonna be a computed SQL query.
Yeah.
All right, that's pretty cool. I didn't know that, but yeah, that's exactly how I envisioned the session to go. Is that we kind of like all out ideas and ask questions. That's
I'll go back later. Like I'll do this definitely like in the works, right? But I'll go back there and see if there's anything that we can improve.
okay.
But I do want to like scrutinize this a little bit more later again. Okay, I think that's pretty good. Do you want to keep going?
Yeah, yeah,
Yeah.
absolutely. So I just wanted to make sure the chat is good. Is chat good? How's chat doing, Edmund?
Uh, yeah, I just talked about OnlyFans, so I think I give them some
Yeah,
drama.
yeah. I was a little bit
So,
distracted by that. So
uh,
it's hard.
Sonia,
Huh?
Dave. Yeah, okay, sweet. All right, so I can definitely not make it all of a career depending on the reaction. I'll just over. Uh,
What did you say?
gotta,
Sorry.
gotta hit four more. All right.
Wait, I think
Dave, anything
someone else
else?
was speaking.
Oh, well, they're sorry, I didn't hear them.
Was things are going pretty good. I just yeah, just because I haven't said anything in a while.
Okay. Yeah, I don't think you said anything at all.
Yeah, that's true.
Cool.
Fire emoji coming.
Emojis coming, chat? Okay. Alright. To be honest, I'm gonna say that it was a little bit. It's much harder to talk about this for an hour and a half straight, but I'm not gonna give up. I said 3 hours, I'm not gonna finish a second earlier, and probably gonna be over 3 hours. Alright, let's keep going. Let's keep going. So we have a primary key of comment, comment ID. It's going to be just a ID. Here we go. Let's make it actually a little smaller. Now, obviously we need to have a comment content, and as you guys might have guessed, This is a video. Um, video. We need a video. Sorry, this is a primary key, and um, secondary key, and then we have a video ID. We have a stream ID as another secondary key. So this is one of them will be null because it's either a video or a stream. It's going to be char set timestamp. It's going to be epoch timestamp. And another thing we need to do, a user who left the comment. User ID. And since this is not like Reddit, we don't actually need to aggregate all the comments made by user. So you know how on Reddit you can see the comments of every single person you click. This is not a requirement for this problem, so we don't need to make this a secondary key. So we will comment ID will be going to the user. It will be going to the video. It will be going to the stream. And yeah, so I think that for right now, we're pretty much done with our database. So we have quite a bit of stuff. Just to go over everything once more time, we have a user table that has a user ID as the primary key. We have all the metadata about the user. We have their status, I guess, if you guys stream it or not. We have their stream ID if they're streaming to the stream. We have their followers as the computed SQL query that is ran every single time somebody follows them. So every single time somebody follows somebody. So for example, when Max follows Babito, what happens is that we will execute the query, and we will this event basically would execute the query every single time new thing is added to here. We'll have the comment table that can be referenced on itself on the video, so we can query all the comments for the video. We can query all the comments for the stream. We cannot query all the comments for the user, so this is not a key. We have a S3 link to the video that is only one singular that is needed to get the link. We have a video table that we can query all the videos made by the users, and we query all the comments made in the video. So they're all very related to each other. As I said, SQL was a great choice. Now we can talk more about primary to secondary partitioning, and let's talk this in depth right now. So we're going yet to another section. Now we're going to talk about scaling. Alright. So is everybody comfortable with different types of consistency for a database, or does anybody need a refresh? Chat?
We could refresh for everyone. We'd be
Yeah.
surprised everyone knows off the top of their head.
Yeah, absolutely. So I'm going to give a very highlighted overview. So first type of consistency is a strict consistency. Strict consistency. We have second type of consistency. Well, there's actually more than three, but I'm going to make it very high level. It's going to be, I think it's just medium, or kind of like, I don't actually remember the exact terminology, but it will make sense in a second. Consistency.
There's strict, sequential, and then
Yeah.
there's casual.
Yeah, sequential. Yeah, thank you. Sequential, casual, and eventual.
Those are the big three, yeah.
So basically, let's kind of go back from the service for a little bit. We have a request coming in to some other service. Let's not worry about TikTok right now. So what we'll do is in every single service we'll have many database nodes. So we have many database nodes. Let's say this request comes as a write request, and we will, and let's say we have another request here that comes as a read request. Doesn't really matter what it is, but what is important here, so let's say for not for strict, this is a strict consistency. For a strict consistency in the exact sequence diagram of all events is that we will write to the node, then this is going to be the primary node. Let's just mark it as P. And then we'll replicate this across the entire cluster. So this is going to be the secondary. And then what we'll do is that we'll return back to the primary with some sort of acknowledgement that the replication has been completed, and only then we will return back to serving, we'll return back here to serving the read requests. So they follow the exact order from top to bottom. Sorry, I wanted an arrow. They follow the exact order from top to bottom. So time order goes from top to bottom. All right. Sorry about that. All right. Okay, so the whole point of this is that we're not serving read requests until the write is completed across the entire cluster. So chat, any questions about that? Chat, Edmund?
No, not for me, unless I'm missing something. Oh, he's out Bobito. Yeah,
Babito?
not for me. Yeah, he just bounced pretty
Yeah.
forward right now.
That's good. Yeah, he's based in Toronto, so it's pretty late for him. Okay. Now we have the. Thank you. Okay. Now we have to cover non-so strict consistency, and the difference is very small for eventual, and I'm really going not into so much details. The whole thing what we kind of need to see is that instead of waiting until the replication is complete, we can serve the writes as soon as the primary database is complete. So what happens here is that as soon as the write happens, we will immediately return back and say that we're done with the write request, and we will immediately start serving the read traffic. And these things, the replication, this is going to be all the async flow. This is the async flow. Let me go right here. This is going to be why does it let me type sync flow? Let's make it smaller. This is everything is done asynchronously. And by the way, when I make say secondary, I don't mean just one node. I mean like there's actually multiple nodes in this cluster, and so is this one. So we'll basically wait for every single thing here to finish replicating before we can serve the traffic back. So yeah, so strict consistency is needed for you guys can think about the type of applications that use that. So maybe like something that is very important, that is always right. So like financial data, stock market, something with money, something that can't be messed up. Eventual consistency, much quicker, but also much less consistent. Obviously, that can be, for example, you have a link to a video, and some users will see it, some users won't, because it haven't replicated across the all nodes. But that is something that is um, yeah, is basically what the trade-off is. Now we also have to talk about how exactly we're going to be replicating the database. So there is many ways to replicate the database, and they're all good for different things. So there is a primary to primary. There is primary to secondary, and there is actually many more. So this is just a way how you probably also heard about it as a leader follower. So that they all mean the same thing. Um, for This is just basically means who can serve read and writes in the database. So for example, in for primary to primary format, what will happen is that both of these nodes, there's actually primary, there's primary to secondary. So there's actually quite a bit more of those. But what can basically to here is that they both serve each other in terms to replicate each other, and both of them serve external read and writes. So both of them accept read and write flow. This is the wrong way. So incoming is write, outgoing is read arrows. And the challenge is that they have to update each other. They have to update each other, and there is not really source of truth. There is just one update each other. No source of truth leader. So that is this format. And there is also primary to secondary, and this can be in many more formats. So we can have primary accepting write flow and replication to the secondary. So this is a replication, goes one way. By the way, there is a need for determining yeah, that's kind of what I mentioned. You need to determine for source of truth, because like whenever there is no sync, you don't know which one to go for. So that's kind of like a big challenge. If this database is saying this row is latest and this one says this row is latest, you don't know which way to go. So what we'll do here is that we can also discuss primary to secondary database. And this format is really good for format where your application is read heavy. For example, our application, we have one cluster of primary that accepts all the read requests, and we have a really big cluster of secondary nodes that accept read requests. And what this basically becomes is that it's much easier for sync asynchronously, so we don't have to upload and this is all async flow, async replica. This basically means as soon as the video is uploaded to primary, we can wait some time for it to be uploaded to secondary databases. This is what we're gonna go with. Again, we have the pros of that, and why I'm gonna be choosing this is that it's gonna have our application is read heavy, plus eventual consistency. From my experience, I found that every single time read heavy application always implies that primary secondary is going to be the best source of truth. We need much less nodes to be in a primary cluster, and consistency is not important, so we can do. There's also algorithms that actually do the replication, and the algorithm for updating the replication I have in mind is many to many algorithm. Is that what it basically does is whenever a node reaches a secondary, it starts spreading like a virus to all the nodes in the secondary clusters. There's a star shape and there's all of them, but we don't really have to focus on this much detail, I guess, for a senior level. So I'll just go with this algorithm and not worry about this too much. All right, there's been a lot of stuff. Do we have any questions?
I would drop a resource if you have one for type of replication strategies that you just mentioned. Haven't.
Yeah, I just read the grokking system design, but honestly, a lot of this comes really from working. I don't really have like a
Yeah,
resource.
if it was mentioned in grokking system design, I must have. Like, I preferred it. Didn't go into depth.
Yeah, I just
At
like
least where
read
we.
it last night, so it's really fresh in my head.
Anyone else in chat have questions,
Chat questions, yeah,
concerns, comments?
yeah. Chat, please be more active. Yeah, I'm really trying for you guys.
No questions for now.
Okay, okay. Does chat want a break? Maybe like 5 minute intermission before next hour and a half.
That would be good.
Yeah,
Okay.
that's not a concert. Fucking.
Yeah, I think I think I need 2 minutes. I need to refill my water
Yeah,
bottle.
Yeah,
I'm down for a break.
take a 5 or 10 minute break. I
Let's
need to
let's
catch up on my notes.
let's meet back at 7:50. How about that?
Yeah, that sounds great.
Okay, I'm gonna pause the recording probably.